form of the Bernoulli's equation is sometimes called the modified Bernoulli's equation, but I will explain that this title, the modified Bernoulli's equation, is not appropriate for this situation. The first equation is the standard form of the Bernoulli's equation and the simplest form, written between 2 points, point 1 and point. This is the pressure force. This one is the inertia or the acceleration. And the third term is the gravity force. And the second relation is the conservation of energy, again written between 2 points. This time, the first term is the work done by the pressure. This was the pressure force. This is the work done by the pressure force. The second term, this time in this equation, is the kinetic energy. This was the inertia. This is the kinetic energy. The third term was the gravity force, but here the third term is the potential energy. As you see, the Bernoulli's equation and the conservation of energy are very similar to each other, but the energy equation contains 3 extra terms which are not included in the Bernoulli's equation. The origin of this difference is that the Bernoulli's equation is the conservation of momentum. It's not expected to see for example, the heat transfer rate in the conservation of momentum, because the heat transfer rate is a quantity which is related to the conservation of energy. So, but in the conservation of energy, or the energy equation, we have the difference of the internal energy of the fluid, or we have the heat transfer term, and the work exchanged with the surrounding. So, these 3 extra terms should be explained. If you omit these terms, the energy equation will be exactly similar to the Bernoulli's equation. The positive and the minus sign here refers to the device, for example, a pump or a compressor and a turbine. The turbine extracts the work from the system, and devices such as pumps and compressor inject energy to the system. So the positive sign here is for devices such as turbines, and the minus sign is for pumps and compressors. If the first hand side, which is again written in the head form with the dimension of length, is the sum of the pressure head, the kinetic energy head or the velocity head, and the potential energy. This package is called the mechanical energy, or the total energy, or the mechanical head, or the total head. This is the content of energy in the input, which is shown by subscript 1, and this is the content of energy in the exit, for example, shown by the subscript 2. You see the content of energy from point 1 to 2 changes because of 2 origins. The first one is related to the devices such as turbo machines, pumps and turbines. Let's ignore this term. And the other one is related to the exchange of heat between the system and the surrounding. And this one is the increase of the internal energy. As you know, the internal energy is related to temperature, so it's related to the increase of temperature of the liquid, for example, or the gas. From a practical viewpoint, the increase of temperature of a fluid is not appropriate for us. So this term is the waste of energy, or the loss of energy, or the dissipation of energy, which is always positive based on the second law of the thermodynamics. But this term can be positive or negative based on the direction of the heat transfer between the system and the surrounding. So the sum of this term is called the dissipation, or the head loss, because the dimension of both of them again is the dimension of length. This is the turbine head or the pump head, which can be added to the system or extracted from it. This one is the head loss, because the increase of the temperature is not appropriate for us. It's the waste of energy, unwanted waste of energy, but this term can be positive or negative for the dissipation of heat. For example, if you touch the compressor behind the refrigerator, you understand that it's hot. The high temperature of that compressor leads to the dissipation of heat based on different mechanisms of heat transfer, such as radiation or convection or conduction. So this term is called the head loss. So the total content of energy in the head form in the entrance, or the point 1, is equal to the content of energy at the exit, or point 2, plus or minus the added or the extracted energy, or the head, in turbine, pump, compressor, and other similar devices, and the rest of energy should be wasted based on the dissipated, or which is called the head loss, based on the conservation of energy.